Hypercalc, what's going on? We're going to look at angle measure today, and our learning target is that you will be able to convert angles to radians. So we learned about radians yesterday. It's a unit of measure that describes an angle rather than just cutting a circle into 360 little pieces. We describe that angle in terms of its arc length. So each angle is going to intersect an arc on the circumference of a circle. We're going to measure that arc length in terms of the radius. One radius is our measurement unit. So one complete circle is 2 pi radians. Okay, so let's see if we can come up with a conversion factor. So we know 360 degrees makes a whole circle. We also know that 2 pi radians makes one complete circle. Those two things don't look the same. They are totally not the same in appearance, but they are equal. They both make one complete circle. So let's see if we can come up with a conversion factor to convert from radians into degrees. So we can take this equation and we'll just divide both sides by 2 pi radians. Laws of algebra, you can do whatever you want to an equation as long as you do the same thing both sides. So on the right-hand side, 2 pi radians divided by itself is going to equal 1. So that's going to basically cancel. And on the other side, we've got 360 degrees divided by 2 pi radians. That's our conversion factor. I'm going to reduce the fraction. So 360 degrees and 2 pi radians. So the 360 divided by 2 is going to be 180. Right, so I'm just going to reduce that fraction, 180 degrees over pi radians, I'll abbreviate. Okay, and then we need a conversion factor to convert from degrees to radians. So I'm going to take this equation, bring that down here, and we're going to do the same approach here. So we're going to divide both sides of the equation by 360 degrees. I'm going to get 1 on the left-hand side, 360 degrees divided by itself. And then on the right-hand side, that's our conversion factor. So 2 pi radians divided by 360 degrees. I got the number part, the 2 and the 360, or reduce. That's just a big fraction. So pi radians over 180 degrees. There's our conversion factor to convert from degrees to radians. Okay, both on the same screen. Here are our conversion factors today. We're going to use just the blue one. We're going to convert from degrees to radians. And so pi radians over 180 degrees. Here is how we can use that. So we're going to convert 30 degrees into radians. A couple of things we should mention ahead of time about radians. We always write radians using fractions, using the symbol pi, and you always reduce fractions. Always reduce fractions. This is like, I don't know how to say that, except I just said it twice. Okay, so to convert 30 degrees into radians, I'm going to take that conversion factor, pi radians over 180 degrees, and I'm going to make that 30 degrees into a fraction. I'm going to multiply straight across top times top and bottom times bottom. So 100, sorry, on the top first, 30 degrees times pi radians. On the bottom, 1 times 180, that's 180 degrees. Sorry, it says degrees. I didn't say degrees. There's degrees. Okay, so units cancel. I got degrees on the top. I got degrees on the bottom. Those cancel. And then the pi is not a unit. That is a symbol. It's going to stay put. Radians, that is a unit. That's going to stay put. The 30 over 180, I'm going to reduce that fraction. So I know that 30 will go into both 30 into itself and also multiply into 180. So it'll be 1 over 6. You could write it as 1/6 pi radians if you wanted to, or more commonly, we'll just put pi over 6 radians. This is what you'll see written more often. We don't need that 1 in the numerator. Just bring the pi over and it'll hold the place. So pi over 6 radians. Second example, let's do 45 degrees. So here is my conversion factor. So I want to make sure that 180 degrees, those degrees are going to go on the bottom to cancel the degrees in the 45 degrees. I know my units need to cancel, so I got degrees on the top with 45 on the bottom over here. I can't remember the conversion factor. That's what I'm always thinking to myself. How do I get those units to cancel? All right, so then we're going to multiply straight across the top, straight across the bottom times bottom. So 45 degrees times pi radians, my numerator, and 180 degrees, my denominator. Let's get some units canceled. I got degrees on the top, degrees on the bottom. That cancels. 45 and 180, I can reduce that. I know that 45 goes into 184 times, so this is like 1/4. So you could write 1/4 pi radians if you wanted to. You could write pi over 4 radians. Both are equivalent. You're going to see pi over 4 more often, and that's what I'm going to encourage you to use. Okay, let's do one more. So we got 60 degrees this time. Conversion factor, pi radians over 180 degrees. Turn the 60 degrees into a fraction, multiply straight across, top times top. 60 degrees, pi radians on the top, 180 degrees goes on the bottom. Degrees and degrees are going to cancel. 60 and 180 can reduce. That'll be 1/3. You can write it as 1/3 pi radians, or you could put pi over 3 radians. Last example, let's move further away from our previous one. We get a bigger number here, 135 degrees, convert from degrees into radians. All right, so I want my conversion factor first, pi radians over 180 degrees. I'm going to multiply that. I'm going to turn the 135 into a fraction, so I can multiply straight across, top times top, bottom times bottom. So 135 degrees times pi radians, all on the numerator. 1 times 180 degrees, 180 degrees for my denominator. I know these units, the degrees are going to cancel in the top and the bottom. 135 over 180, this numerical portion here, I'm going to try to reduce that. And then the pi radians, this thing is going to be left over. So let's see if I can come up with a way to reduce 135 over 180. I know that they're both divisible by 5. It looks to me like I think 45 is going to go into both. 45 times 2 is 90, 135. Yeah. Okay. 135 divided by 45, that's 3. The numerator is going to be 3 pi radians. And 180 divided by 45, that's 4. 3 pi over 4 radians. Or if you prefer, 3/4 pi radians. Either way, both mean the same thing. So that brings us to the assignment for today. You're going to add the radian labels to a unit circle. So you'll be provided with degrees. You need to come up with those same angle measures, but in radians. You can convert each one of them around. Always use exact form. Exact form means you're going to leave it as a fraction, and you're going to leave the symbol pi as part of your answer. Improper fractions are the thing to use. Don't change these into mixed numbers. So the answers we just came up with, pi over 6, that's 30 degrees, pi over 4, that's 45, pi over 3 for 60 degrees. We didn't do some of these. Actually, we looked at a couple of these, if you remember from yesterday. But 135 degrees, that's the one we just did, is 3 pi over 4. And that's it. Good luck. See you next time.